Hello and welcome to Mechanical Y. Here I have a ball. Now I'm going to drop this ball and let's observe where it lands. So where did it land? Well, it landed right about there. But let's be a little more precise. I'm going to drop this ball and let's predict where it's going to land. Well, you might say that it's going to land directly underneath where I drop it. Now this is when I tell you that you're wrong. The ball is not going to land directly underneath where I drop it. It's going to land somewhere else. Now before we go into explaining where this ball will land that isn't directly underneath it, let's do a bit of a thought experiment. Let's say I drop the ball from this height. Where is it going to land? Let's say I drop the ball from this height. Where is it going to land? Let's assume I build a very, very tall tower and drop the ball from that height. Where is it going to land? Well, let's assume I go to the tallest tower on Earth, the Burj Khalifa in Dubai. It's about 820 meters or 2,722 feet above the ground. If I drop the ball from that height, where is it going to land? The answer is it's going to land a little bit to the east of directly underneath where I dropped it. So why is that? Gravity pulls things down, not to the east. So what's causing things to move to the east? Well, gravity sort of pulls things down. Gravity pulls things towards the center of the Earth, which we happen to define as being downward in most circumstances. But there's something else that's actually causing this to drift to the east. And we have to remember something about the Earth. So let's look at the Earth. The Earth is actually round. It's not flat, which means that down is in different directions as you move around the Earth. The second thing you must remember is that the Earth is actually spinning. And it's actually spinning towards the east. So let's say I take an excessively large tower. Let's say I could build a tower this tall, and let's say I smack it right there on the equator. What do you notice about the tip of this tower as the Earth spins? You'll notice that the tip of this tower is actually traveling faster than the base of this tower because of the Earth's rotation. So the tip up here is moving faster in this direction towards you than the base of the tower is. And this is what causes the ball to drift to the east. Because at the tip of this tower, this ball already has a little bit of speed relative to the ground going towards the east. So as I build tall towers and drop balls from them, the velocity that that tower already gives the ball at the very tip, due to the Earth's rotation, will pull the ball to the east. So what happens if I keep building a tower taller and taller and taller? Let's say I keep moving up and up and up. Does that mean the ball falls further and further to the east? The answer is yes, it does. It'll continue to fall further and further and further to the east. That is, until it hits a critical point. Let's say I build a tower about 23,800 kilometers tall, or about 14,800 miles tall. And let's say I drop the ball from all the way up there. Now you notice that this ball at the tip of that tower would have a lot of velocity to the east relative to the ground. So what happens? Well, I'll notice the ball will start accelerating generally towards the Earth, but it'll start moving to the side to miss the Earth. And then it'll continue moving around. It'll actually pass the atmosphere completely, and right when it hits just on the other side of the Earth, it'll miss both the Earth and the atmosphere completely. It'll move around, continue, and it'll actually come back to the tip of that tower eventually. So what happened? The tip of a tower this tall, moving relative to the Earth, actually gives the ball enough velocity that it actually achieves Earth orbit, and it completely misses the Earth as it tries to fall back towards it. So what happens if I keep going taller and taller? Does that mean the Earth stays in orbit? Well, yes, it'll actually achieve new orbits the taller you go, and the shape of this orbit will depend on the height of your tower. That is, up until you reach another critical point. Let's say you build a tower approximately 35,700 kilometers tall, or 22,200 miles tall. What happens if I were to let go of this ball from a tower that tall, spinning around the Earth? The answer is nothing. The ball will simply sit there next to my hand. Because you see, a tower this tall reaches a very important point around Earth. That point is geosynchronous orbit. The tip of this ball is given enough velocity and is placed at just the right position relative to the Earth that it'll actually enter an orbit where it appears to stay directly over a single point on the Earth. And that ball will stay there forever up until it's perturbed. So what happens if I continue to build a tower even taller than geosynchronous orbit? Let's say I keep going taller and taller. What happens then? Well, it won't stay above a single point, but it will achieve a new orbit. And this orbit will continue to expand up until you reach a final critical point. And this is the tallest you can make a tower and still see a unique result from the ball. Let's say I make a tower 46,700 kilometers tall, or 29,000 miles tall. What happens to the ball when I drop it from that height? Well, the tip of that tower has a great velocity relative to the Earth. In fact, that velocity is so great that when I let go of this ball, it's going to start moving towards the Earth, it's going to miss the Earth, and it'll continue going out, and we'll probably never see it again. So what happened? The tip of that tower gave the ball so much velocity due to the spinning of the Earth that it actually achieved escape velocity for that altitude, which means that that ball will just fly away. We'll never see it again. That ball has enough velocity to leave the Earth's gravity. And if I continue to make the tower taller and taller past that point, it'll just continue entering into a new escape trajectory. And that ball will leave and we'll never see it again. So let's stop making the tower taller. We can't really build towers that tall anyway. So let's consider what happens if we move away from the equator and start moving north or south. What do you notice about the tower? Well, the tip of the tower at the equator has some velocity. But as I move towards one of the poles, the tip of the tower's velocity isn't so great. In fact, the closer and closer I get to the pole, the less and less and less of a velocity change that tip has, until I reach the pole itself. Now at this point, I have reached the axis of the Earth's rotation, and the tower is perfectly aligned with it, which means that as the Earth spins, the tip of the tower will not actually move relative to the ground, which means if I drop a ball from a tower built on exactly on top of one of the poles, it will fall straight down and hit directly underneath where I drop it. Now this is true of both poles, and this is true no matter how tall I build this tower, because the tip never has additional velocity over the ground. So I can actually pass geosynchronous orbit, and I can pass as far as I want. As long as this ball still feels the effects of Earth's gravity, it'll fall straight down. So let's go back to this experiment. Let's say I drop the ball from this height. We know it falls to the east, but how far to the east did it actually fall? Well, in this particular ball's case, that's about 2 nanometers to the east. That is a tiny, tiny, tiny amount. In fact, we can hardly observe it with our naked eye, and we would need specialized equipment to find out exactly where it lands. And in the end, it would actually be a moot point because there are other factors that would affect where this ball lands from this height. Crosswinds will move it, spin on the ball will actually cause it to drift. So from this height, it falls pretty much directly underneath where I drop it. Other things affect where it lands more than just the rotation of the Earth. But let's say I go up to the top of the Burj Khalifa, 820 meters up. And let's say I drop this ball from there. And I drop it from a special rig that goes out from the side of the tower so it doesn't hit the tower on the way down. And let's say I make this ball very, very heavy. Let's say I make it out of something like lead, and it's extremely heavy so things like air resistance don't really affect it. Where will it land? Well, I shine a laser straight down from where I think it's going to land, and then this ball will actually land about half a meter to the east. That's about this far, which means I can measure it quite easily. I'll observe the laser pointing straight down, and I'll observe the ball slowly drifting further and further to the east, and I'll be able to see a difference with my own eye, and I'll be able to measure that difference with tools easily available to me. So why is this important? Well, we can't really build towers that tall, and there are a lot of other things that affect where a ball lands. Like I said, air resistance, spin on the ball, or hitting objects on the way down. But it is a very important thought experiment because you think of the Earth as not being flat anymore. You think of the Earth as being round. And you have to remember that the Earth spins because this changes the result of different thought experiments. Furthermore, it brings into consideration new things like Earth orbits. You can't just think of this Earth being flat and then building towers tall and objects always falling. There are points where objects will no longer fall in the way we traditionally consider towards the Earth. So it is important to think of things like this because it gives you a new perspective on treating our Earth in a different way, in a more accurate way. And this more accurate way of thinking of the Earth is important when considering things like satellites and other spacecraft, or even things like the moon orbiting the Earth. And things like that are reasons why we perform thought experiments like this. So, thank you for watching. I hope you found this interesting. Please like and share this video if you did find it interesting, and please subscribe to stay up to date on new content.